surrounded by electricity. It impacts every part of our lives. It flows through our homes, giving us light and heat. It's in our phones, giving us the other essentials, Facebook and Twitter. It's even in our brains, telling our bodies to pump blood and to breathe. But what do we mean by electricity? Sure, it's the flow of charge from one area to another, but why do we think that it's so dangerous? In 1897, Mr. J.J. Thomson's experiments proved that something smaller than an electron was causing charge to flow between areas of high voltages and areas of low voltages. But at the time, everyone believed that atoms were the smallest particles in the universe. So this finding was astounding. The scientific community was shocked. It was like Galileo saying that the world was round, or in today's terms, like Simon Cowell trying to tell us that One Direction has split up for good. This astounding result means that there's charge flowing between high and low voltage. But actually, these electrons are tiny negative particles, and they flow between areas of low voltage up to areas of high voltage. And in order to flow, they need a voltage difference and some kind of connecting path. So, if you consider a pond which sits at the bottom of a hill, the ducks living in that pond will see calm and peaceful waters. But if we build a connecting path between that pond at the bottom of the hill and one at the top of the hill and start sucking the water up to the top of the hill, those ducks will experience something of a roller coaster ride. And it's this flow of water that's very similar to the flow of electrons. But there's something else at play. If we have something called low resistance, the water will move quickly, just like the electrons and the current will move quickly, and it'll be quite dangerous for those ducks. But if we increase the resistance and use something that moves slower, like we replace the water with honey, the ducks will have a much more pleasant ride, but they'll be a lot more sticky. And it's that fast flow of electrons that's dangerous to humans, and of course to our ducks. So that's why we're told, don't put a knife in the toaster, because if you do, you're making your body the connector between the low voltage in the ground and the high voltage on the toaster. And the electrons are going to flow through you, and just a rule of thumb, no knives in the toaster. But what about birds who sit on electrical cables which bring power to our houses? Why isn't it bye-bye birdie every time they land on a cable? Well, those birds are electrically isolated. They sit on one particular voltage at one particular cable. But if they did reach their wing over and touch two cables at the same time, suddenly that connector is in place, and that's when you're going to get some fried crows. So if you do want to stick your knife in the toaster, please make sure you're jumping off the ground when you're doing it. We now know that it's actually the flow of electrons and current that's dangerous for people. So the next time you see a sign that says, danger, high voltage, we know that that's just voltage getting a bad name. It should really say, danger, high current.
Thank you, Aisling.
Well
Lovely.
done. Why did you decide to tell us that story?
I studied electrical engineering as undergrad, and I just think people, it's a common misconception that the current is flowing from the positive to the negative side, and I just think it's important to show, that actually what we think is completely wrong, so it's nice to kind of startle yourself sometimes, and it's also important to understand electricity further, because it is everywhere. As I say, it's even in our brains. It's actually what helps us store memories and move our muscles, so it's important to understand how prevalent it is and how it actually works.
Great, well done.
Alison O'Shea.